This conference will now be recorded.
Okay, so we're looking at the last module, module 4. And I want to also acknowledge as many of you as this class is true for module 1, module 3, and also at the last module, which is module 4. And in module 4, we'll be considering some key topics. Remember that this mentoring program is to arm you with the foundations of system administration and network administration, giving you the basic fundamentals, that which you need to start and also work within the role of a system admin or a network admin. So we're looking at computer hardware and software, basic operating system troubleshooting, installation and customization of Windows operating system, Active Directory. Okay. So we'll be looking at computer hardware and software. Now, for some of you are new to IT. Some of you are actually IT professionals. Now, irrespective of whichever side of the coin you fall, whether it's a professional or not a professional in terms of computer or IT, there's one basic concept of computer science, which computer constitutes of hardware and software. They tell us that the hardware is those things you can touch, you can feel, those things that are tangible. So your computer system, those things you can touch is your hardware. And examples of computer hardware includes input devices, output devices, storage devices, internal components.
This conference will now be recorded.
Okay, so we have input devices such as your keyboard, your mouse, whatever it is that you use to enter data into your system is your input device from the word input. There's also output device such as your printer, your monitor, the things that displays the results of whatever it is that you've put and has been processed by your system. Then you have storage devices such as your hard disks, your CD, DVDs, USB. You have internal components such as CPU, motherboard, and RAM. So these are majorly examples of computer hardware. Now, the computer software talks about the set of programs which is built to perform in a well-defined manner. So the software is that which you can touch that runs on the computer. Remember when we're talking about operating system, we're able to highlight that the operating system is a software. So it's a software that serves as an intermediary between you, the user, and the computer. So it gives you the graphical user interface, it gives you the command line interface. And in computer software, there are two types: the system software, such as the operating system, the assemblers, the interpreters, the compilers. For some of you who has done programming, you understand what a compiler is, what an interpreter is. There are also application software such as your Microsoft Office, your web browser, your payroll software, your whatever application that you run on your system, whether it's Adobe Reader, that is an application software. Then the system software are those that interact majorly with the hardware, such as your operating system, your compilers for people who write code and they need to compile their code. Now, what is the difference between both of them? So typically, they are equally dependent on each other. The software needs the hardware to run. The hardware needs the software to run. So they are mutually dependent on each other. So you can't have software without hardware. You can't have hardware without software. So our software cannot be utilized without a supporting hardware. Hardware is without a set of software programs cannot really operate. So to have job done on the computer, you need the relevant software loaded into the hardware. For instance, if I give you a Windows 10 CD, if I give you an Ubuntu CD and I tell you that, okay, take this operating system, start using it, it won't make any more value to you unless you have a system, a laptop, a desktop to install it on. If I also give you a laptop without an operating system, it will be of no use to you. So they are interdependent. Now, one of those components of a computer too you should have an idea of is the motherboard. So there's what we call motherboard. Now, the motherboard serves as a single platform to connect all the parts of the computer together. So just like in a family that you have a mother, the mother is the one that brings everything. It's like mother hen. A hen carries all the chicks within her to cover all of them. So the motherboard is like a single platform, a single plane where every component of the computer sits on. So it has the CPU on top of it, it has the memory on top of it, it has the hard drive connected to it, it has the optical drive, your CD drive connected to it, your video card. Every component is like the center of gravity. That is what we call the motherboard for a computer, and this is how it looks like. So for some of you who are new to IT, if whatever form of system, even your phone has a motherboard. Your phone has a motherboard. Any computer system that you have or you use has a motherboard. So whether it's a desktop, whether it's a laptop, whether any tablet, it has a motherboard where every components are connected together. So this is how a desktop looks like. These are some of the components of a motherboard for a desktop PC. You have CPU heatsink, you have many connectors here. Now for a laptop, so a laptop also has a motherboard. This is how the motherboard of your laptop looks like. So you have the fan, which is the heatsink. This is the heatsink. You have your RAM that is connected here. You have your wireless card. You have many chipsets and capacitors that are connected. You have your USB, you have your VGA, you have your HDMI, you have a slot for hard drive, you have a slot for CD-ROM. So all of these components are part or what make up your laptop. So everything you see in your laptop is connected in one way or the other to the motherboard. Now, so that's just the basics of computer hardware and software. So these are just the foundation. So whether it is a server, whether you are working in an enterprise environment where you have many servers running or in a data center, these basics remains constant. So whether it's a big server that has maybe 50 terabytes of RAM or 50 terabytes of hard drive, have maybe 2 terabytes of RAM, whatever dimension, they will have a CPU, they will have a memory, they will have a storage, and they will have a motherboard. So these are the basics. So when you understand these basics, in whatever environment you find yourself, you'll be able to have a grasp of these things. So basic operating system troubleshooting. Now, one of the things in IT you will do times and times over is what we call troubleshooting. To troubleshoot. To troubleshoot actually means to find what the problem is and to solve it. So it's more like a process of solving a problem, determine what the problem is and solving it. Because systems and computers, when you leave them to work, time and times over, they will continue to have issues. Issues will just come up. Maybe your system shuts down or your system crashes or your system freezes. Those are issues that might come up with your system, that might come up with a system. Also in networking, we also have network troubleshooting because issues might come. Maybe a port isn't working, maybe you're not browsing. All of those issues may come, and the way to resolve them is through troubleshooting. So troubleshooting often involves a process of elimination where a technician will follow a set of procedures to determine the problem or solve the problem. So first of all, when you have an issue, what I do most times for operating system or for systems, I'll first of all ask myself, this issue, is it a software issue or a hardware issue? Now, if anybody complains to me that his laptop is having something, he has one issue with his laptop, with his system, the first question I'll first of all try to answer, is it a software issue or a hardware issue? Now, if it is a software issue, you will know which software is the one having a problem. Is it Microsoft Office? Is it the operating system? Do I need to install the operating system? Do I need to, if it's the driver, do I need to install the driver? So all of those things come in because I know it is a software issue. But if it's a hardware, it's either I replace it or maybe I dust it or blow this thing out of it before it works. Most of the times, even in computer, in laptops, in desktop, when a computer equipment spoils or is damaged, what you just do is replace. So what you do, replace. So it's only when you are more like a hard-end electrician or technician where you go into the motherboard and soldering one wire or soldering one capacitor. But most engineers, even in computer, what they do, if your hard drive gets spoiled, they change it. If your RAM gets spoiled, they change it. If your power pack gets spoiled, they change it. So that is one of the things you get to understand or learn. So first of all, getting to know what is the root cause, what is the problem, and see how you can solve it. So getting to know what the root cause, is it a hardware issue or a software issue? If it's a software issue, it's easy. We install the software, maybe do a restore, whatever form, just to resolve the software issue. But if it's a hardware issue, most times, or most likely, after you must have cleaned it, dusted it, and it's still not working, you need to replace it. Now, operating systems are not designed to utmost perfection. So operating systems can crash, they can have issues at any point in time. So you need to understand that these issues would occur. Most of these problems are either software or hardware. So software could be virus, driver, corrupt application, missing program files. Hardware could be RAM, hard drive, SATA cable, processor, power pack. Now, these are some of the basics which you can troubleshoot an operating system if there are issues. Now, is the computer turning on? If the computer or display is not turning on, you can quickly determine that the computer has a power. So let's say a system does not come up, it does not boot up. You need to check, does it have power? One, is there power entering into the system? If there is no power on a system, there is no magic on earth you can do that will make that system to come up. It must be connected to a power source. You also have error messages. Error messages are also key. One of the beauty of computing or IT generally is that the error messages gives you idea of what issues are on the system. So it gives you idea. It gives you idea of the issues that are present on the system. Don't despise any error message you see. Read it. Best case, you just Google it. Just copy that error message and Google it, and you will see better interpretations to it or possible fixes for it. So those error messages are very key. You can write them down and you research on those error. You research on those error messages. So you can also reboot the computer. It will amaze you that one of the quickest fix to many issues on a computer is just a reboot. Restart the system. I've had many instances where systems was misbehaving and you just restart it and it starts working. Maybe it could not connect to a Wi-Fi, maybe it was not seeing USB for some reason, and just restarting the system makes it fine. So rebooting the system might be a fix for you. Another thing also we also look at is that has any new hardware software been added? Now, when someone complains that his system is having issue, the first question I ask the person, what was the last thing the person did? What was the last application that the person installed? What was the last hardware that the person replaced? So let's say the person say, okay, last week I had, let's say the person say, okay, last week I don't know, I changed my RAM and this week the system is freezing. Then it tells you to a great extent that, okay, let's check the RAM that you replaced. That gives you an idea. Someone could say, okay, I installed one app, one game, and since then my system has been misbehaving. You will need to check that game. So all of these things also help in troubleshooting. You can also scan for malware and viruses. If you have an endpoint security and antivirus security solution, you could use to scan. We could use to scan the system. What to do if troubleshooting does not help? The goal of troubleshooting is to try to isolate the problem by eliminating the possible. So even if you have gone all through these steps, I assure you can ask an expert. One of the things in IT you will learn to do is learn to ask people who know more than you or people who are more experienced. So if you're having issues with a computer, having issues with your network, you can seek expert advice. You can seek expert counsel that, okay, this is the issue I have. The person will be able to point you in the right direction. So it is very, very key. Nobody is a monopoly of knowledge. So even the experts still consult from their peers, from their friends on key issues. Now, installation and customization of the Windows OS. So we will run through this in our hands-on lab. I'll teach you how to install a Windows operating system. And this is a reference link that can teach you how to install a Windows 10. So now the last part of the module 4, which we also do in lab, is Active Directory. Active Directory. Now, Active Directory is one of the uh, latest innovation, or it's not even latest. One of the key understanding a system administrator must know. The reason why is that most enterprises use Active Directory. So this is how it works. Now, because enterprises like banks, like big companies, they have thousands, maybe hundreds of computers, maybe Windows 10 operating systems in different branches, and they want to centrally administrate them. When I mean centrally, like you stay at one place and you're able to control what the website the users can visit. You want to control the activities, if they should not use a USB cord, if they should not install an application that is not authorized. You want to have control over their system. So Active Directory gives you that advantage, that power, where from a central location you can administer many systems. You can administer many systems from one central location. So what happens is that you create a domain for your company. A domain is like an area you get within Active Directory that you create. So you create that domain, you give it your company name. So maybe you say ABCD Enterprises, that is your domain name. Then you add all your system to the domain. What it automatically means is that as you are adding them to the domain, the Active Directory, which is the controller, has control over them. So a system administrator does not need to be going from system to system to be installing application. You don't need to go from system to system to be doing stuff. From a central location, he can control each of those pieces. From a central location, he can create users. He can do whatever it is that he needs to do rather than going from one place to another. That is what an Active Directory does. And we will see a practical application, a hands-on, either today or tomorrow, where we'll build an Active Directory service, a domain of an enterprise, and we'll add system to it, and we'll see what we can do. We can create users, we can create policies, we can push policies. So that is Active Directory. So, and a server running Active Directory domain services is called the domain controller. So there's a controller. An example of Active Directory is like in airports. You know, you have the control tower. The control tower controls all the aircraft in that airport. So before an aircraft takes off, before an aircraft lands, they must consult with the control tower. The control tower gives permission as to who to fly and who not to fly, which aircraft to fly and which aircraft not to fly. So that is how it works here. So there's a domain controller, like a tower, like a controller that controls all the systems wherever they are on the network. So an example is when a user logs into a computer that is part of a Windows directory domain, Active Directory checks the submitted passwords. Now, One of the beauty of Active Directory is that you can, if any system on the Active Directory domain can be logged into by all the users. So it means that, let's say I am in finance department and my system is on Active Directory. I can log in there and do my work. And let's say I found myself in sales department. I don't need to carry my system from finance to sales. Once I get to sales, I will log in with my username and password and I will enter my profile automatically. That is one of the beauty of Active Directory. So you can go to the office without being particular as to which system you need to work. You can go to the office, you can go to your work and not being very specific as to what laptop you need to use, because every laptop on the domain, you can log into it and have access to the network. So that is what the Active Directory is. And in 1999 was when it was first released in Windows Server 2000. So, and in some way, these are short modules. We looked at computer hardware and software. We looked at basic operating system troubleshooting, installation and customization of Windows, which we will do hands-on. We also looked at Active Directory, which we will do hands-on. Thank you.
Thank you, sir.
This conference will now be recorded.
Yes. Okay. So we'll look at our hands-on lab for networking. So remember, we've been working on this lab for a while, and today we hope to finish it. And in our last class, we were able to do static routing. Static routing was able to allow us that a PC here in Port Harcourt, is able to reach the earth water. So if we do a ping, so I think if I remember, the AD is 10.10, 192.168.10.10. Okay, it will skip one of them will fail, then the others will. Okay, so it's replying now. So usually, because of things like app, things like learning MAC address mapping, you might have timeout, maybe 1 or 2 or 3 timeouts initially, but once the traffic goes through, it becomes consistent. So that's why you don't just ping only one try, you ping at least 4. So even a normal ping is defaulted to 4 tries. So out of 4, it will send 4 packets and see how many it receives. So if you look at here, you see I sent 4 but I received 2. I get 50% loss, but when I ran it again, I had 0% loss. So that's ping. So from here, I've been able to ping Lagos. So let me see if I can ping. Let me see if I can ping Abuja. The IP address of this one is 200.12. Remember that this IP address was gotten via DHCP. So let's ping 192.168.200.12. So see, it's now replying. So from Port Harcourt, I can reach Abuja. And we did this last class using static routing. And let me just do a brief recap of what we did. So let me enter our enable password, which is Cisco. Our privilege, our console password is Cisco. Our enable password is Cisco123. So if I do show IP route, you will see here, you will see these 2 SS. So this is static out. Look at this S here. The S here is labeled static. Where's S here? CS static. What I just did was to show the routing table. So if I want to check it, how I configure, if I do show run, which is the running config, you can see what I configured here. So this is what is making Port Harcourt reach Abuja. We configure static routing on all the routers for them to be able to communicate with each other. And this is where we stopped. So we said we'll continue with a dynamic routing, and we also said that we'll work on the wireless. So leaving the static routing, pausing it, let's work on the wireless and test. So I remember that I told us that this wireless, we're using this wireless that is here is a lightweight access point, and is not what we are supposed to use. Now, I didn't want to delve much into wireless technologies, but in wireless, there's also the idea of a controller and a access point. So it's just like you have the Active Directory controller and you have endpoints here and there. So in a network where you have like 10 or 11 access points, you don't want to be logging into all the 10 one by one and be configuring them, because that would be too much. Now, in such a network design, what you do is use a wireless LAN controller. So from that wireless LAN controller, you can control all the wireless within your premises without having to log into one of them by one. Just like the system administrator lying to log in or go from seat to seat to be able to configure something on people's systems. So because this is, we're not using a LAN controller, a wireless LAN controller here, we'll delete this wireless, lightweight wireless access point. So this is for delete. So let me delete this, let me delete this, and let me delete this. What we just need is a standalone access point. And how do we get standalone access points? Let me magnify so that you could see. So this is wireless. So this is Meraki, Lab PT, lightweight access point. This is a wireless LAN controller. These are the models. Then you can see from here access point PT. So if we carry one, you see access points. So this is what we'll use for access points. Okay, it's already connecting. Why it's connecting is because it's open. Okay, yeah, I know the reason why it's connecting already, because I attached the wireless adapter to this laptop. So, but let's configure. Let's look at how the wireless access point looks like. So when I open it up, this is what I see. So I see an interface here. I see power on, power off. And when I go to config, it tells me the name of the access point. Port 1, it tells me, okay, is the wireless on in terms of beaming, what do you call it now? The LAN interface, if it is on. Then this port 1 here is where you see SSID. So the SSID is the name of a wireless access point, the name. So just the way I am here, I can see Modupe, I can see iPhone. All of these are what we call SSID. These are SSID for wireless. So first of all, I want to connect a cable, a straight through cable between the switch and my access point. Yes. Okay. So I also want to configure an SSID. So let me say HQ Wi-Fi. Okay, just give me a second.